Okay, I guess we'll get started. Again, appreciate everybody taking the time. Our target's about 30 minutes for this, and then we'll have reviews afterward. If you want to add some questions to the Snap, Mike or Rick will try to answer them as we go. Try to keep everybody muted throughout this, and we'll do the questions afterward. So we have we have veterans here as well as newcomers. We're going to be doing a Kyntronics review when we're across the table or through virtual. A lot of times people ask, hey, where did this really amazing product come from? What's the genesis of it? We'll kind of go through that, give you guys some insight into that, also review the product. So that'll be a review for others, and it'll be new to some of you. And we'll dig into some of the lifting overview, challenges, etc. there, and talk about servo control and software. And we'll get into some specific lifting examples and some unique challenges and unique solutions, some common challenges throughout them. We'll just jump into this. So Kyntronics has been around for about 10 years. It's an innovative company. We're focused on motion. That's where a lot of the team came from. We have a core team that's been, of course, with us for the 10 years, as well as another 10 years prior to that through various companies. You have electrical, software, mechanical, hydraulic engineers all on staff. So originally, we developed EMAs and electronics for high-end seat control that most of us never get to sit on in aircraft. There was a need with a major OEM who approached us and said, hey, we need some innovative technology, and we went down the road with them. So flying on an aircraft is really challenging. Reliability standards, certifications, etc. that we had to go through. That same OEM asked us to develop a EHA to put on a seat. The seat you're looking at on the screen was the first EHA seat in the world, and that was displayed in Hamburg of 2013. So that was our first experience with EHA. We thought it was a unique solution, learned a lot on that, and went out to the market. We learned that really there isn't a big market for the low-end, small, tiny EHAs. And you can see the large 84,000-pound EHA is where we progressed to. So that's the genesis of it. That came from uniquely a product that we're not selling today that's going into seats. So during the development process, it was important for us to develop a modular solution. We have over 1 billion combinations. But our focus was to try to maintain standards, maintain and minimize our inventory, but have a large breadth of product offering out there. So various motors, a couple of different manifolds and pumps, power units. We can provide a panel or enclosure for an all-in-one solution. And our standard is 1-inch to a 6-inch cylinder. That's up to 84,000-pound force. So some of the repeated quote themes just wanted to share with you about this product is amazing. Usually we get that after we deliver the product. Where's this product been type thing. It's an amazing product to sell. It's unique. It's different. It's not a Me Too product. The all-in-one is also a nice advantage. Those are, again, some repeated themes. And we'll kind of review some of these as we go through the slides. So the basics of the SHA. This is obviously a repeat to some of you. It's pretty simple. You have a servo motor connected up to a positive displacement reversible pump, gear pump, and you rotate the servo motor clockwise, for example, pushes the fluid into the red, pushes the piston up and extends the actuator, and vice versa, counterclockwise. Blue retracts the actuator. The green is your reservoir for compensating for the rod volume. The most efficient actuator on the market. There's no metal-to-metal wear. It's an extremely efficient solution. again up to 42 tons, and you can synchronize these together as needed if you need increased loads and increased speeds. No hoses, no threads, no leaks. The gear pump, you're using a gear pump. Well, the gear pump is surrounded by oil. There should be no metal wear. Top and bottom, there's films of oil it rests on. Oil squeezed together. The shafts have oil on them as a support bearing. So it's a total hydrostatic type sealing. No metal wear on the gear pump, or we have some issues. Just showing you down here is how we increase our speeds. So 0.7 gallons per minute is a small guy, up to 7.8 gallons per minute is a big guy shown on this particular screen. This is your basically your transmission. Of course, the bigger guy takes a little bit more power, a bigger motor, but it's a very simple, easy solution to increase speeds. And each one of these can take your 3,000 psi, so your torque's there. And again, this just increases your flow just by making your gears larger. Simple circuit. We provide optional cavity plug, check valves, or solenoids depending on your needs. For pressure sensors for force control, both in retract and extend positions. 4-quadrant control, and not much going on here. Relief valves on every single actuator, both extend and retract. This helps protect the actuator as well as the machine. A lot of our competition in this world can only do 2-quadrant control. We're doing 4-quadrant control. The beauty of hydraulics is that it's just fluid. It can be moved in all kinds of different directions. These are some of our standard. We've shipped all these different combinations. This helps us be able to integrate into all kinds of different machine orientations. Again, it's just moving fluid, and that's the beauty. We really don't have any issues figuring out a way to get our actuator to fit into a machine without doing any major redesigns. Down below, just see various configurations. You can attach the enclosure electronics to the actuator if needed. For a DC solution, electronics and motor are all enclosed as an IP68 solution. Of course, we can provide an actuator by itself, customer supplied motor and drive, or something custom.
Hey, Carl.
Yes.
I know I told you a moment ago you were coming through loud and clear. We've had a couple of comments that you're sounding a little muffled. If you're able to adjust your microphone position, that might help.
We'll do that. Mounting options, NFPA mounting options, standard mounting options. Nothing too surprising here. Just wanted to show you that all the standard mounting options, NFPA type things are available. Sometimes we get comments saying, hey, this particular customer says that no hydraulics. With the Kyntronics actuator, there's hardly any fluid in there. It's minimal fluid. You can point them down the road regarding gearboxes. Gearboxes in their plant have more fluid than our Kyntronics actuator. So just as a point, there's not a lot of fluid inside the Kyntronics actuator. It's very efficient. Closed system, no hoses, again, no amount of fluid. So the all-in-one's important. Just wanted to point out that sometimes this is challenging. It's been challenging for our competitors. It's challenging out there for everybody. And our goal was, we're a solution-oriented company. We like to try to make the complex simple, and we're focused on that, trying to make the all-in-one a simple solution. So we have standard sizing, standard drawings, standard software. So our team, as well as our channel partners, are used to the software, setting up the actuators, setting up the wiring up the drawings, or wiring up the actuators, etc. So this is an important part of our offering. We like to try to take care of the customer however we can, and this is how we're doing it. And then, again, the apples to apples sell is somewhat challenging out there, to make sure that we're competing against a proper actuator only or somebody else, an integrator, providing the whole solution. Some of our partners also provide the all-in-one, Rockwell, Siemens, etc. We have an AOI for Rockwell. They can also provide, and they also do provide the all-in-one. So going over some of the lifting, getting in the lifting world, all-in-one again is that one-stop shopping. Hey, we want to be able to have this thing supported, etc. So we're doing that. Increased emphasis on going green, this ESG scorecard. That's the environmental, social governance thing that's getting more and more popular. That some companies have the scorecards, and it's important to some companies. So the environment, of course, is our part. Increased loads, lifting challenges, increased loads, synchronization, safety, manual operation. Some lifting applications require manual operation on power failure. Connectivity is also a challenge, IoT, etc. Overhauling loads, regen, four-quadrant control, and of course the position accuracy. These are all just some of the challenges regarding the lifting and somewhat in actuation. So what's available to the actuation, to the lifting companies? Obviously, you have the hydraulics that are available. Proven technology has been around for decades. High force density, powerful, robust, can plow through most of the machine inefficiencies. There's no brake required. Shock or side loads. Shock loads are no problem, obviously, with hydraulics. And somewhat can be a cost-effective, simple solution for just moving back and forth. Another technology is the EMA world, Acme ball, roller screws. That main advantage is the ease of control. Easily you can configure the parameters, and modify as needed. Power and demands, also a nice, important advantage of the EMA. It only runs when needed, opposed to the hydraulics. It needs to run continuously. Very inefficient. Of course, there's no hoses, no leaks. Simple interface to the PLC. Some of the challenges regarding the EMA and hydraulics, metal wear, of course, we're all aware of that. Load dependent, as load increases, reliability decreases. Shock loading, side loading are all enemies of the EMA. Got to avoid that. Maintenance with the metal wear is always something that needs to be lubed up and continuously, or that lubrication goes away. Ingress protection is also an issue. It's expensive in order to make sure nothing comes into the EMAs. On the right-hand side, of course, it's the hydraulics world, some of the challenges, environmental issues, leaks, continuous running motor, floor space. You can't program these things too easily. Maintenance, continued maintenance, and upgrading. The HPU is a fixed unit, fixed horsepower. If you want to add cylinders, you got to upgrade the HPU. So keeping those advantages and challenges in mind, the SHA truly combines the advantages. We're going to go through some of those and highlight some of those throughout this presentation. So it does combine the advantages, takes advantage of the assets regarding the hydraulics as well as the mechanical, and it also solves a lot of the challenges. Best of both worlds. Servo software, control capabilities. A lot of you seen this before, the position control, force control, position and force control. You can switch at any time with no bumps. Position control with force limiting, that's the most popular selection. All these are standard. They all can be selected on shipping the order. We'll test here, of course. Four-quadrant control, synchronization, as mentioned, you can increase the loads, increase the speeds by paralleling units up, coordinated motion, compound moves, and if needed, we can do custom programming for OEMs, etc. All this is included in the AOI for Rockwell. So synchronization, So some of the challenge regarding synchronization, lifting, of course, you got to synchronize actuators together in a lot of cases. For hydraulics, it is very challenging, very expensive, all kinds of different fluid paths, flow controls to make sure the actuators are syncing together when you really need that, 5 thou or better type synchronization. It gets expensive. With EMAs, their advantage is they do the digital lock, which of course the SHA takes advantage of that. That's what we do. The EMAs have backlash, require sometimes match lead screws in order to properly sync and accurately sync. They also require a brake to lock position. Again, the SHA takes advantage of the technology that's out there for the EMAs. It uses that for digital lock and doesn't have a brake. You don't have backlash. So as soon as you stop, the brake locks into position. Again, this is an example of taking advantage of the hydraulics as well as the EMA technology while solving some problems. Regeneration, regarding regenerating, overriding loads. Where does that power go when you're trying to control? And hydraulics, we use a counterbalance. That creates a bunch of heat. You have a spring kind of adjusting the flow. It's challenging the control. And again, it adds heat to the fluid, which is something that we try to avoid. With the EMAs, they use dump resistors, and that's what we're using. But some of the challenges regarding EMAs, it's difficult locking into a position. Obviously, you use the brake. You have to stop, make sure you're at 0 speed, and then you engage the brake. If not, you get premature wear. So that's something that we don't have to worry about. So as soon as you stop, the solenoid goes on or the check valve is engaged to ensure the actuator's locked in position. So again, we're taking advantage of some of the hydraulic features, the locking features, and taking advantage of the EMA features regarding the regen. So we're taking advantage of both and solving problems with the SHA itself. As mentioned, the AOI we have developed with Rockwell. All the software features are already mentioned, all the control features that we've already mentioned. So this is a nice solution for the Rockwell companies or the Rockwell customers that need the Rockwell solution. We are a technology partner. Used to be called Encompass. We are a technology partner and are working with them to spread the word. So some of the lifting examples, kind of going into some of the details, list challenges. We got about 8 or 10 examples here. So this particular example is regarding the security wedges, security wedge lifts. They needed higher loads, increased speeds. Sometimes it's a tight fit into their wedges. We figure out a solution how to get in there. Liquid ingress, IP67 or better is important. Manual operation upon power failure, you need to be able to either lower or raise the lift as needed. We solved all those. So the IP67, just out of the gate, the actuator is an IP65 actuator. We add some better connectors. We enclose the motor. As you can see here, the motor's enclosed. This is our power unit. Power unit puts flow into this unique block that's 45 degrees and the cylinders here. So this was made to fit into this particular wedge. There's the motor, the pump's in here. This is a secondary manual pump with a connection that you can use a drill to raise or lower the actuator. So this is, again, a nice feature for the security business. Also, DC backup power is available as needed. The Navy had a unique need regarding 2 modes, selectable modes. They wanted one actuator to do both. In the past, they had to switch out actuators. They did not want hydraulics inside their testing facility. They wanted a 240 speed change and about a 5 times load change, which is very difficult. You can see one half an inch per minute is very slow. So we just added a diverter valve that's actuated based on a solenoid. So when they want to switch modes, they just turn on the solenoid, and that diverter moves fluid in 2 paths, one going into the reservoir, the other slowly trickling into the actuator, and they're accurately controlling that to do material testing. Again, the preferred solution was the Kyntronics SHA. This particular example of lifting was lifting a large chip head position. The chip head is 8,000 pound force, needed to raise it up and down, over and over again. They had issues with hydraulics in the past, actually caused a fire in their facility, so they want to eliminate the hydraulics. They wanted the all-in-one solution. They're kind of out there in nowhere's land, so they wanted to be able to call and contact one company and have things solved. So that's what we provided, the all-in-one. Of course, no EMAs regarding the shock loads, so we were the, again, preferred solution for this particular application. Another lift example is in the medical/food industry. This one was a required food grade oil. There's another one that wanted an all-in-one solution with an HMI, unique field bus, integration, IP67. They wanted caustic washdown, provided that through the epoxy coating of this particular actuator. This was a vat, as well as moving things into a smoker type environment. So they wanted increased load, speed capability, along with precision. We provided all that to this particular company. 55-inch stroke. This was a coordinated paint lift line. They had an old, antiquated mechanical system in the past. They wanted the all-in-one as well. No finger pointing. They needed accurate positioning. On his particular one is interesting. The stories we got regarding some of the quotes. This product was amazing. They started bringing in their upper management to show them the actuator and how smooth it was, how quiet, how accurate. They were amazed on its performance, and they're buying more. It's interesting, lately we've been getting a lot of AGV inquiries. This particular AGV OEM was a forklift project. Again, they wanted the all-in-one solution, 48 volt DC, which is a little bit different than the normal 230, 480 volt world that we're familiar with. They wanted to eliminate hydraulics. Extended life was an important factor. They were looking at roller screw technology as well as us, but the roller screw technology didn't meet their life needs, and we did. They also had some unique CAN bus requirements, and so again, the all-in-one, we provided that solution. So it was basically, this is an OEM, so we provided them a custom DC solution as well as actuator that, again, met their needs. This particular AGV user was a large electric vehicle manufacturer. They have plants all over the world. They were getting down towards the 11th hour, and they didn't have an actuation solution. So this is kind of an interesting story. They sent an email on a Monday through our internet. They found us on the internet. On Tuesday, we had a call and provided them a crude concept, to see if there really truly is interest here. There was interest. They gave us some more information. On Wednesday, we gave them a little more accurate concept. And on that following Friday was a little more production-like actuator. You can see the actuator here. It's a very odd looking actuator. This is the power unit. This is the cylinder. You can see the cylinder here is wrapped inside these scissors. There's two scissors on this AGV, and the power unit itself is wrapped around and need to be at a certain angle, so when it lifts up, it doesn't hit things. This doesn't show it, but there's all kinds of equipment, and there's batteries in here. So they had a really challenging need, and we met that. And in a week or two after, we received POs and we're off and running with them. DC solutions, synchronized motion. This is again a standard solution that we provided them regarding our CAN bus interface, standard CAN bus interface, and along with AGV safety circuits, etc. So this particular one box goes into each AGV right on top of the batteries, and they were thrilled to find us. 4-axis coordinated lift solution. This particular one, they again wanted the all-in-one solution with a field bus integration, synchronizing the 4 actuators together. IP67, it's outside. You can see the motors were enclosed. IP67 connectors, etc. So it replaced an unreliable rack and pinion system. And of course, they needed the precision-ish, with the extended life was the more important feature. So they need to synchronize together, avoid the binding as it's climbing up. So this was an interesting need from this particular military. Can't get into too many details, of course. You can appreciate that. But they're looking for us to retrofit existing cylinders. They required high speed and a high load needs. Our standard off-the-shelf actuator didn't meet the high speeds and high loads. Plus, they wanted to keep their existing cylinders. They're proven, and it's outdoors in a particular environment. They had 2 solutions out there trying to solve this particular need. They have EMAs and they have hydraulics, and both are headaches for them. They originally had hydraulics. They went to EMAs. The EMAs are failing. Now they're back to hydraulics, and they don't want to go back to the complex, messy hydraulic solution. So they wanted an all-in-one. They were kind of let us know that they had some issues with the EMA. The EMA integrator, you can say, was buying actuators from one supplier, buying a motor from somebody else, and buying a drive from somebody else, and putting it together, and they were having issues with the finger pointing. So we're able to provide them an all-in-one solution. They also wanted coordinated motion. They had multiple cylinders. So below what you see is, won't get into too much detail, but basically it's our power unit. And they kept their standard cylinder, and we paralleled up 5 power units to increase the speed to meet their speed needs. They wanted a manual release valve and some pressure sensors, etc. So again, this is our standard power unit, commercial off-the-shelf power unit, one supplier, one solution. We're able to synchronize these cylinders together and meet all their needs. So this is a little bit, new news to our supply channels and our customers out there. So this is another product offering that we're going to be offering soon. Is a Servo power units and using our standard power unit. This is a reservoir and hose connectors. Yes, we say, hey, no hoses, but there's a big demand for this. Not necessarily wanting to replace all existing cylinders, or like the prior slide, they want to keep the cylinders for environmental reasons, etc. So we can do this. A lot of our competitors out there have something like this, and we already have it. So there seems to be a need in the field, and we're going to be offering this as a solution as well. It's the same drive, motor combination, and all the calculations we already have. So we're looking to sell this as well. As mentioned, we can parallel these things up to meet high loads and high speeds. Redundancy, that's another factor I forgot to mention, and you can take these on and off as needed to keep redundancy available. So as wrapping up, the challenges all in one: going green, increased loads and speed, synchronization, safety, connectivity, overhauling loads, visuals and accuracy. You can see EMAs. Some EMAs, or the EMAs, can achieve some of those challenges. Hydraulics can achieve some of those challenges. The SHA can achieve all of them. So the SHA is the preferred solution for these challenges, as well as the your future actuation needs as required. All right, any questions?
Carl, we did have some questions on the chat window. You want me to read those for you?
I can take a look here.
So for instance, we had a question regarding using our force sensors for meeting safety requirements. Does the position control with force limit meet safety requirements? And I would say, although using pressure transducers for calculating force and controlling force is a tried and true technique, it's not intended for use as a safety limit or as a safety sensor.
It all depends on what you define as the safety from my perspective. So in some instances, it could be. In some instances, you may need some other additional devices. So I think we need to look at the specific requirements to properly answer that.
Right. And for instance, the drives that we use have a safe torque off input that's usually wired into a customer safety circuit. And we'll gladly, like Carl said, look at your safety circuit, make specific recommendations as to how you can achieve that. The next question was, what about heat from continuous high duty cycle applications? How do we address eliminating or preventing the pump and the fluid from overheating?
Today we use, there's multiple things that affect heat. That is pressure and flow, and we try to size appropriately to make sure that those are, I guess, minimized. And there's ways to do that. We also use fans on the heat device, which is the pump. We have heat sinks and fans on that. For the high duty cycle, high pressure, high flow needs, we can use external coolers, again, as required.
Right. And as you mentioned earlier, something important to keep in mind with our design, because it is power on demand, we're only going to be moving that fluid and energizing that motor and introducing heat to that pump when motion is required, totally unlike your traditional hydraulic system that is generating heat because they're running that motor continuously over spillover valves, that kind of thing. So it's really important that we do some educating of our market space as to how different we are, how unique, how much more efficient we are, even than electromechanical in many instances, and why that helps reduce the heat. But like Carl says, we have the ability to mitigate heat in whatever your requirements for your specific installation and applications are. But knowing that duty cycle in advance is very important so that we can do our job properly in sizing this thing with the right size motor, pump, reservoir, all those important criteria. The next question, Carl, was, do we have field service available in Europe?
So we're continually looking to add partners in Europe as needed, and we do have some, and we need to continue to add more.
And so if you have a specific customer that wants contact information on who our partners are that can provide that local support in Europe, will gladly provide you with contact information. And if you know of partners that are interested in our technology, we'd love to talk to them as well. Rick, you have a specific request for the forklift slide from one of your contacts, so you'll make sure you follow up with them. We've had the question, is the presentation going to be available after? And we will be posting this to our website like we have all of our previous presentations. That'll probably require a few days, maybe give us a week or so. And then the other question, and I haven't looked recently, is please talk about what maintenance is required for this design.
So yeah, basically it's a maintenance-free solution. There's oil in there, and you don't have to replace the oil. You know, in that 30 to 50 million, depending on the application and the running cycles or inches. I'm sorry, like Mike said, you can replace the rod cartridge, and at that time you could replace the oil or keep the oil as is. So it really is, you got to need, obviously, depending on the environment, you need to make sure the fans, if there's a fans on there and the heat sinks are clean. But other than that, you just blow them out every few weeks, once a month, and you're good to go.
Right. And then another new question, is there compatibility of your actuators with other brands of controls such as Siemens? And of course, the answer is yes. We're in the actuator business, not the motor and drive business. You can use really any commercially available combination of motors and drives. We'll tell you exactly what input torque and speed is required for our pump to provide you with the output force and speed for your application. We'll even provide you with, yep, go ahead.
Yeah, let me jump in for a second. Yeah,
Sure.
The other thing I'd like to say is that, you know, Carl talked a lot about what we're doing with Rockwell. And I just want to make the point that our relationship with Rockwell is purely technical. They're really, we don't have any kind of commercial agreement with them, you know, to favor their distributors or anything like that. You know, the technical stuff is really the focus there, and that, yeah, we're open to working with anybody. And in fact, we've got a similar program started with Siemens that we did with Rockwell for an AOI.
Right. Yep. So we're really agnostic. We don't care whose motor and drive. We want you to use our actuator technology with whatever your clients are asking for in terms of the control, and we'll help them make sure that they know how to set it up, configure it to be successful working with this very cool, compact, robust design. Another question that came out is, what do you mean by 4-quadrant versus 2-quadrant control? Carl, you want to take that one real quick?
Yeah, real quick. So you have your 4 quadrants and your 2 axes being basically flow and pressure. And with 2-quadrant control, you have to, let's just say you're doing position control and you're coming into position. Let's say you want to target at 4 inches. You have to slow down and creep into that 4 inches. With 4-quadrant control, you can overshoot slightly and back up. You don't have the backup capabilities with 2-quadrant control.
Basically, you're able to control that whatever regenerative energy and use it for your motion profile, which helps speed up the duty cycle, the throughput. Another question, for low speed applications, can you describe the difference in performance between a standard pump and the one you mentioned with the solenoid earlier? I'm not sure if I'm following that. I might have missed that.
So there's various things, and low speed means one thing to one and another to somebody else. So if you're talking like 0.5 inches per minute, that's very low. And what we do on that is divert flow to a around in the reservoir, and then divert some flow into the cylinder. And that allows you to go really slow. We also do multi-pumps today. You can go with the lowest pump, size 2 pump type thing, even do some diverting on that if needed, and then you can switch over to the higher speed as needed. Hopefully that answers your question.
Yeah, and we'll gladly dig into any of these applications in more detail with you as needed. And then the last question that I see here, Carl, is for a very long stroke actuator, where is the oil kept?
Well, the oil is in both sides of the piston, of course, and the reservoir. And that's in the oil cycles between the reservoir that compensate for the rod. It's really that simple. So no matter how long the actuator is, the reservoir will grow with it.
Yeah, so we're not all things to all people. We've been asked to quote things as long as 20 feet, 24 feet long. Those obviously require a lot of fluid. So we can't eliminate the need for fluid, but we have been able to get it down to mere ounces versus using gallons. And then our totally sealed design eliminates the filters, eliminates having to top off or replace or replenish the fluid to keep it maintenance free. So there's a lot of advantages for the designs, for the applications that we can address and solve, but we're certainly not going to be all things to all people.
Yeah, and I think part of that question about the reservoir came from the fact that when we get to the larger diameter cylinders, we have an external reservoir. So that might have been what prompted that question.
Okay, sure. And we've got PowerPoint slides that show various configurations and designs that use anywhere up to our standard 6-inch cylinder. We'll be glad to share that with you if that helps as well. And that was all the questions that we saw from the chat room. Anybody else out there that still wants to ask, feel free to jump in.
Well, there's two more questions, one being STO. The STO,
Oh, didn't see that.
the STO does drop power to the motor and drive. Of course, you still could have the 24-volt power to the drive, so the drive's not going to totally shut down and comms aren't going to shut down. And then there's in standalone, are you able to do 2 cylinders, or do you still need a separate? No, well, depending on what you need to synchronize. The example I provided has multiple cylinders, so those units would be paralleled together to run the 2 cylinders. I don't know if that makes sense, but yes, we could do 2 cylinders with no issues.
Well, except you still have the traditional problem with dividing up one hydraulic power supply over multiple cylinders. You have to make sure that there are components in there that divide up the flow equally to multiple cylinders.
Right.
If you want really good coordinated motion between multiple cylinders, the best way to do it is, one pump, one cylinder.
All right. Hopefully that answers it. Then if there are any other questions, feel free to contact your local sales rep or RSM, or contact the office direct. Appreciate you guys taking the time today.
Thanks, Carl. Thanks, everyone.
Carl, appreciate it.